Chapter 6, we're going to look at exponential growth and decay functions. And so we're going to look at graphing an exponential growth and decay function. So first we want to identify the value of the base. In this case, the base is 2. And so we want to know, is that greater than or less than 1? So we know that that is greater than 1. So if we know it's greater than 1, then we know this is an exponential growth. So we're going to make a table of values. We're just going to plug in a few numbers. So -2, -1, 0, 1, 2, and 3. So we're plugging each of these into our x values here and solving. So when we plug in 2 to the 0, remember anything to the 0 power is 1. Then we plug in 2 to the first power is 2. 2 squared is 4. 2 to the third, remember that's 2 times 2 times 2. So therefore this is 8. So let's go to the other side. Let's go 2 to the -1. Now remember with a negative exponent, what that means is you take the reciprocal of what it's attached to. So therefore this becomes 1 over 2 to the first power, or just 1 over 2. Then 2 to the -2, what that means is you take it, you do the reciprocal, now it's a positive exponent, and then you square it, so it becomes 1 over 4. So let's graph it. Now, the important thing to note about this is that the graph always has the point 0, 1 if it's not shifted anywhere, always at 0, 1, because anything raised to the 0 power is 1. Then the next important point is when you plug in 1, it is always whatever that base is. So our base is 2, so notice, if I plug in x as 1, my base is 2, so it's always at 1, comma b. And so we mentioned that, or maybe you saw that in the notes. So here, let's plug in the rest. So at 2, we're at +4, and at 3, we're at 8. 5, 6, 7, 8. So we're all the way up here, grows exponentially. Then, on the left side, the negative x's, if we plug in -1, we get a 1/2. And then the next one, to the -2, that's a 4th, and it keeps going. It keeps getting smaller and smaller, and keeps approaching this x-axis here. And remember, this x-axis is our asymptote. So this is our graph of y equals 2 to the x. So let's look at the next one, 1/2 to the x. So the value of the base is a 1/2, so that's our b. And then we know that that is less than 1, so therefore it is an exponential decay. So I'm going to pick these numbers here, -3, -2, -1, 0, 1, and 2. So 0 at 1/2 to the 0 power, remember that's always 1. Then 1/2 to the first power is 1/2. Then 1/2 squared that's 1 over 2 times 1 over 2, which is 1 over 4. The -1, so remember, if we have a -1, what that means is it flips in the inside, so it's 2 over 1. Now it's a positive exponent, so the answer is 2. For 1/2 to the -2, you flip everything, and then you square it, so it's a 4. And then for 3, that is 2 cubed, that is 8. So notice how the numbers kind of are flipped here. Not that we're flipping the x and the y's, but notice that at 3, it's at 8 for a 2. And then at -3, it's an 8 for this one here. So just kind of looking at the pattern. Let's finish graphing this. So at 0, 1, we're here. At 1, we're at a 1/2, right? A 1/2, so whatever that base is. And then it gets smaller, okay? Then on the left side, when we plug in -1, we get a +2. When we plug in a -2, we get a +4. -3, we get a +8, somewhere up here. So here's our graph. And then again, our asymptote is here on the x-axis, and please draw it because, get you in the habit of drawing it as we go on and we start to shift them up, down, left, and right. That'll be very helpful to remember. Now next, you're going to try to graph these on your own. So here are 4 of them, 1, 2, 3, and 4. Now what I want to do, number 1, you need to circle whether it's a growth or decay. So, choose each one, whichever one you think it would be, and hopefully using the information we talked about earlier. If it's greater than 1, it's a growth. If it's between 0 and 1, then it's a decay. Number 4, I want to change that. It's 1.5. I want to rewrite that as a fraction. So this is 1 1/2. So I want to write it as an improper fraction. So in order to do that, you multiply 1 times 2, and then you add it to 1, just as a reminder. And so this becomes 3 halves. So what I want you to do is graph this one, 3x. So I just changed the 1/2 to a 3 halves. So try these out. The numbers that you're going to choose are -2, -1, 0, 1, 2, and 3. Now I know that you can only fit like a couple, like here you're only going to be able to fit these 3, but more than anything I want you to practice. Can you evaluate each one given these values? So hopefully you tried this out, and these are the values you should have gotten when you plugged it in. So notice for x you get at 0 is 1, 1 is 4, 4 squared is 16, and 4 cubed is 64. When you plug in -1, you flip it, so it's 1 over 4, and then -2 is 1 over 16. And then you can only graph, like I said, those 3 points, which is fine. So on the homework, just choose, the 3 values, -1, 0, and 1, and maybe a little bit more, depending on how small the number is, how small the base is. So this one maybe have been a little bit challenging for you, but 0, you plug in 0, it's 1. You plug in 1, it's 2/3. If you plug in 2, you square the top and the bottom. So 2 squared is 4, 3 squared is 9. Same thing with 3. So it's 2 cubed, which is 8, 3 cubed, which is 27. Now with the -1, you just flip it around. So then instead of 2/3, it is now 3 halves. Then to the -2, it's flipped over, it's a reciprocal, and then you square it. And then here is the graph. And approximating is pretty good. It's just good to know how to plot these points.